Alright, so as we get started, we're going to first start by looking at parallel and perpendicular lines. And so, parallel lines will go in the same direction and never touch. Perpendicular lines, they will touch, they will intersect, but what makes them special is that when they cross, they make a right angle. And then my third example, so the lines are either going to be parallel, perpendicular, or neither. And when lines are neither, that means that they just cross, they just intersect. So now the question is, well, what makes lines parallel? Two lines will be parallel if they have the same slope. Two lines will be perpendicular if their slopes are opposite reciprocals. And two lines will intersect if their slopes are different. Alright, so let's look at an example. For each of the following, determine if the lines are parallel, perpendicular, or neither. Be sure to state the slope for each as justification. So, first, these two equations are already written in the form of y equals mx plus b. And what we care about for looking for parallel perpendicular is the m, because the m, the slope, will tell us what the lines are doing. So if we look here, the first equation has a slope of negative 2/3, and the second equation has a slope of 3/2. So the slopes are definitely different, so we know that the lines cross. So the slope of the first one is negative 2/3. The slope of the second one is 3/2. So since the slopes are different, we know the lines cross. But now let's look a little closer. Are the signs opposite? So here we have a negative. Here we have a positive, so we have opposite. Now we look at the number, 2/3. What's the reciprocal of 2/3? Well, the reciprocal of 2/3 is 3/2. So we have a negative, we have a positive, so we have opposite. The reciprocal of 2/3 is 3/2. So we do have our opposite reciprocals, so these two lines are perpendicular. And the reason is because the slopes are opposite reciprocals. So now as we look at our second example, and notice that it's not in slope-intercept form, so the first thing we have to do is we have to take both of these equations and put them in slope-intercept form. So as you're following along, a good thing to do is to try this on your own, pause the video, and then come back and check your work. Did your work agree with mine? Alright, so slope-intercept form means we want the y all by itself. So we're going to get rid of the minus 3x on this one. And so we always do the opposite. And so this goes away, And so now I have 2y equals negative 3x plus 10. Now I need to get rid of the 2 in front, so I'm going to divide both sides by 2. When I divide by 2, everything gets divided by 2. And so this becomes y equals negative 3/2 x, and then 2 can go in the 10, so plus 5. And now let's look at the other equation. And again, this would be a good time to try it on your own and pause the video. Alright, so now since this is a negative, we're going to do the opposite and add 6x to both sides. So this goes away. Don't forget about the minus here. So we get minus 4y equals 6x minus 10. Now we need to get rid of the negative 4 in front, so we divide everything by negative 4. And so now negative divided by negative gives positive y equals negative 6/4 x, and negative divided by negative is positive 10/4. And so now as you look at these two and say, oh, well, they're different. Well, before you say that, let's go ahead and see if we can reduce our fractions. And so our negative 6/4 is going to become negative 3/2, and 10/4 is going to become 5/2. And so as we compare these now, we're looking at the slopes, the number in front of the x. So we have the negative 3/2, negative 3/2. Since they're the same, we say the lines are parallel. Okay, so the lines are parallel because the same slope. Now let's look at another example. This time we're going to graph, and I'm going to give you just the points here. So we'll do the first one in red. So we have 5, 3, so we go to 5, 3, negative 5, 2, negative 5, negative 2, and that's our first line. Pretend it actually hit the dot. Let's see if we can fix that. Okay, let's try the next one. We'll do this one in green. Alright, so we have 6, negative 2. And 4, 5, 4, 5. That's not an easy line to draw on this thing, so let's try again. Alright, well, let's pretend it's actually a straight line. And so as you look at that drawing, hopefully your drawing's better, you might think they're perpendicular. They're definitely not parallel. So to be sure, what we're going to do is we're actually going to find the slope of each line. So let's start by finding the slope of line 1. And to find the slope, all we're going to do is we're just going to do the rise over the run. And that's basically saying how much are the y values changing over the x values. So what I do is I just count from here to here, and I make what we call a slope triangle. So I go up 1, 2, 3, 4, 5. So I went up 5, and then I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so my y is here. This is how much I'm going up. x, my run is how much my x values are changing. This is the x-axis. So it's 5 over 10. You always want to reduce your slope. So that gives us 1/2. Now we're going to do the same thing for the green. M2, slope of the second line. So now, really pay attention to the dots. Kind of ignore my line because my line wasn't very good. And so I'm going to draw the slope triangle. And now I'm just going to count. 1, 2, 3, 4, 5, 6, 7. So I went down 7, so it's a negative 7. Negative 7. Over, and then, where's my cursor? 1, 2, I went over 2. And this can't be reduced, so my slope here is negative 7 over 2. And so now we look at these, and we want to compare them. Well, they're opposites. This is a negative, this is a positive, but to be perpendicular, they have to be opposite reciprocals. And so the reciprocal of 1/2 is 2 over 1. The reciprocal of 7/2 is 2 over 7. So obviously, these are not reciprocals. So although my drawing might look perpendicular, when you actually investigate the slopes, they're not. And so we would say neither here. Or you could say the lines just intersect.